The race to get back to the moon is on. And this time, it actually happened. For over half a century, the footprints left by the 12 Apollo astronauts have remained untouched on the lunar surface, standing as a quiet reminder of Cold War rivalry. Through NASA's Artemis program, the goal was to return to the moon by 2024, and this time, not just leave footprints, but to build a more sustained presence and support future missions deeper into space. Like most large-scale space projects, it hasn't gone exactly as planned. There have been delays, technical challenges, and budget overruns. The first mission, Artemis I, an uncrewed test flight, launched in November 2022 after multiple postponements, successfully demonstrating the core systems. Then came Artemis II, the follow-up that the world waited for. Scheduled for 2024, flew in 2026. Make of that what you will. 4 astronauts are now in deep space, farther from Earth than any human has been in over half a century. And the mission they're on is the opening move in something much larger than a moon flyby. So, what is Artemis II? What took so long? And what does a 10-day loop around the moon have to do with the future of human civilization? Let's break it down. After Apollo, NASA didn't exactly go quiet. The space shuttle flew for 30 years. The International Space Station has been continuously inhabited since the year 2000. But all of that happened within about 400 kilometers of Earth. The Moon is 384,000 kilometers away. That's nearly 1,000 times farther. Going to the Moon requires a completely different class of rocket, a different type of spacecraft, and a whole different set of risks. After Apollo 17, the political will and budget for all of that simply ran out. The Cold War space race was over. America had won, and there was no immediate reason to go back. For decades, the Moon was something we admired from a distance, until something changed. Scientists discovered water. In 2018, NASA confirmed what orbital data had been hinting at for years. The permanently shadowed craters at the Moon's south pole contain water ice. Billions of tons of it. That changes everything. Water isn't just for drinking. Split it with electricity, and you get hydrogen and oxygen, the same ingredients used in rocket fuel. Suddenly, the Moon isn't just a destination. It could be a refueling depot, a launch pad for deeper space. That's when serious planning for a return began. Artemis II is not a moon landing. Let's be clear about that up front. The mission is a 10-day crewed flyby. 4 astronauts fly out to the Moon, loop around it, and come back to Earth. No landing, no moonwalks. But that framing undersells what's actually happening here. The 4 crew members are NASA astronauts Reid Wiseman, Victor Glover, and Christina Cook, along with Canadian Space Agency astronaut Jeremy Hansen. On launch day itself, several historic records were set. Victor Glover became the first person of color to travel beyond low Earth orbit. Christina Cook became the first woman. Jeremy Hansen became the first Canadian. And together, they are the first humans to leave Earth's neighborhood since 1972. The rocket carrying them is NASA's Space Launch System, the SLS. It's the most powerful rocket ever launched, producing around 8.8 million pounds of thrust. That's roughly 15% more than the Saturn V rockets of the Apollo era. On top of that sits the Orion spacecraft, which handles power, propulsion, and life support. The mission profile goes like this. The crew spends the first day in Earth orbit testing Orion's life support systems. On day 2, a burn sends them toward the Moon. Over the next 4 days, they cruise through deep space while conducting experiments and system checks. They then loop around the Moon, flying as far as about 407,000 kilometers from Earth, before returning for splashdown in the Pacific Ocean. At its farthest point, this crew will be farther from Earth than any human in history. The previous record was set by Apollo 13, and that crew wasn't exactly having a good time. So if they're not landing, why is the world's space community so excited? Because Artemis II is a test flight, and test flights are what separate plans on paper from things that actually work. NASA's Orion spacecraft has never had humans aboard in deep space. The life support systems, the radiation shielding, the navigation and communications at lunar distance, all of this has to be verified with a real crew before anyone attempts a landing. The mission is also testing the Orion capsule's manual control capabilities, including proximity operations. Essentially, how well an astronaut can maneuver the spacecraft relative to another object. This matters a lot for future missions, where Orion will need to dock with a lander in lunar orbit. On board, the crew is also running a set of scientific experiments, including one studying the effects of deep space radiation on human tissue using organ-on-a-chip devices. Deep space radiation is one of the biggest health risks for long-duration missions, and we still have a lot to learn. In short, Artemis II is building the foundation. Every system that works on this mission is one less unknown for the missions that follow. Here's where things get ambitious. Artemis II is step 2 in a longer roadmap. After this comes Artemis III, which will test orbital rendezvous and docking with commercial landers in low Earth orbit. Then Artemis IV, currently targeting 2028, aims to put boots on the Moon for the first time since Apollo. And the target is very specific: the lunar South Pole. This region has permanently shadowed craters where temperatures drop below -200 degrees Celsius. Those extreme cold traps have preserved water ice for billions of years. Nearby mountain ridges, by contrast, sit in near-constant sunlight, perfect for solar power generation. It's an ideal location for a base. NASA's long-term plan is an Artemis base camp, a permanent outpost at the South Pole. The agency has said it plans to spend around $20 billion building it. The goal isn't short visits, but sustained presence, missions lasting weeks or months, where astronauts mine water ice, extract oxygen, and eventually produce rocket propellant on site. If it works, it dramatically reduces the cost of operating in deep space and makes the Moon a real stepping stone toward Mars. NASA is targeting biannual launches, one every 6 months, to build up the logistics chain for that kind of sustained presence. There's another reason this program carries urgency, and it's less about science and more about geopolitics. China's space agency, the CNSA, has been moving fast. In 2019, China became the first country to land on the far side of the Moon. In 2024, Chang'e 6 brought back the first samples ever collected from the lunar far side. China has already placed multiple satellites in lunar orbit to support future missions, and it's targeting a crewed lunar landing by around 2030, with a permanent base at the South Pole by 2035. China and Russia are co-developing what they call the International Lunar Research Station. The world is effectively splitting into two lunar alliances: the Artemis Coalition, led by the US with Europe, Japan, and Canada, and the ILRS Coalition, led by China and Russia. Why does this matter beyond national pride? Because the South Pole's water ice isn't infinite. Whoever gets there first, establishes infrastructure, and begins extraction sets the precedent for how lunar resources are governed. As NASA Administrator Jared Isaacman put it, the clock is running, and success or failure will be measured in months, not years. Artemis II won't put footprints on the moon. There's no dramatic landing sequence, no iconic photo of an astronaut standing on the surface. But what it does is something arguably more foundational. It proves that the hardware works, that the mission architecture holds up, and that humans can safely travel to the moon and back with the systems we've built. Thanks for watching the video. If you find this informative, please give it a like and subscribe to our channel. Until next time, keep looking up and stay curious.